We're in Chapter 10. As we get further into the course, or practically through the course, not actually, but pretty close to being through the course, we start to see some of the real statistical concepts come together to create statistical procedures. So confidence intervals is one example of that, and now we're talking about hypothesis testing as another example of a procedure that happens in lots of areas of statistics. We are just looking at a couple of examples, but it's one of the primary techniques people use to determine whether or not it looks like there's been an impact because of a treatment or if there's been a change in conditions based on the sample. And here we go. So it says up here, section 10.1, introduction to hypothesis test. We could say introduction to hypothesis testing. So what hypothesis testing does is it tells you whether a certain value of a population parameter is supported by the data. All right, and so our progress so far looks like this. We use the sample proportion to estimate the population proportion using a confidence interval. We use the sample mean to estimate the population mean in the same way, using a confidence interval. And now we concluded, at some stage of the game, if the hypothesized value of either the mean or the proportion is not in the confidence interval, we could say that the value is not supported by the data. So the confidence interval is based on the sample mean or sample proportion. If it's too far away from the hypothesized mean or hypothesized proportion, the confidence interval will not contain that hypothesized value. And we'll say, based on the data, it doesn't look like that hypothesized value is correct. Alternatively, if the observed statistic, the mean, sample mean, or sample proportion, appears to be more than 2 standard deviations from its proposed mean. So that says it's pretty far away from where you would expect it to be based on the assumption we're making. We can say that the value of the proposed proportion or mean is not supported by the data. Okay, from its proposed mean. So this proposed mean would be a value of p if you're looking at proportions, or a value of mu if you're looking at means. So the statistics we're using, the sample proportion and the sample mean, are centered on the true value. And so if they're far away from a value, that value is probably not the true value. That's the idea. So here's the beginnings of setting up the framework for hypothesis testing. Here we go. So there's a bunch of steps to it. The first step is creating a null hypothesis and alternative hypothesis. So the null hypothesis is the assumption of no change in the parameter value. So you're thinking, well, that's usually what it is. It's this number. And the alternative hypothesis is the suspected type of change in the parameter. So we can expect to see an increase, a decrease, or just some kind of change, depending on the experimental situation, or depending on what the purpose of the study is. So you might want to know, say you're looking at, pick something like global warming. You might want to know whether it's changing rainfall. And you don't know whether it's an increase or a decrease, just wondering, has there been a substantial change? In which case the alternative would just say that the, say, proportion of rainy days is not the same as it used to be. Could be higher, could be lower. And we know the typical proportion, that'd be the null hypothesis. Or you might wonder whether the introduction of unsweetened soft drinks has caused the average weight of Americans to change. Some people think artificially sweetened soft drinks would be making us fatter, and other people say, well, it should be making us thinner. So we could say, is it doing anything? And that would be the alternative then would be, has the mean weight of the population changed at all? Of course, that's pretty hard to know because lots of things change the mean of the population, not just artificially sweetened drinks. The null hypothesis would be the mean of the population the same as it was. So what does that look like here? There's 3 kinds of alternatives. Here's one for proportions. The null hypothesis always looks like parameter equals number. And the alternative looks like parameter not equal to, parameter greater than, or parameter less than the same number. So these numbers have to match. So you might be testing whether or not the passing rate on a physical fitness test, what fraction of the students are passing the physical fitness test in high school. You know, the typical proportion was 75%. You might be thinking, well, I think kids are more fit now, so I think that proportion went up. Or maybe I think kids are less fit now. Let's see if the proportion went down. Or let's just see if fitness changed at all, up or down, I don't care which. And you might be studying that in response to maybe a different kind of physical education program where maybe they get to pick what they want to do, go bowling, go running, play basketball, whatever, compared to the typical PE program where there's a prescribed routine that everyone has to follow. And you might say, well, maybe people would be more likely to stay fit if they could have more fun, so let them pick what they want. Okay, that's possible to study. And then over here, if you're studying the mean, the null hypothesis is mean equals number. Possible alternatives are mean not equal to that number, mean greater than that number, or mean less than that number. So first you have to identify a number which the population mean could be, and then you have to see whether your sample indicates it's not that value, and it could be just not equal to you care about, or greater than or less than you care about. When you're looking at this greater than or less than situation, if you see information that makes it look like the mean went down, then you go, well, what I was looking for didn't happen. And so since this is the usual mean, and I was looking for an increase, if I see a decrease, I just say, well, it looks like the mean hasn't changed the direction I expected it to, and I will just go on with business. That the thing I was looking for to be causing a problem, that problem didn't happen. Maybe the opposite problem happened, but maybe it wasn't due to the cause that I was studying. Okay, so that's our introduction to hypothesis testing. The second step is going to be, once you've defined the null and alternative hypotheses, to look at a test statistic. And then the third step is drawing conclusions from the value of that test statistic. And we'll be getting to that pretty soon. Right now, I'm closing this screen.